In the middle of an ocean storm, a gigantic car carrier ship is transporting more than 10,000 vehicles through waves several meters high. The ship begins to list dangerously. Steel structures rumble under the immense load, and inside the hull are thousands of brand new cars worth hundreds of millions of dollars. A single mistake here is enough to turn thousands of vehicles into a pile of scrap metal, causing damage so massive that it could be considered one of the greatest transportation disasters in history. From the outside, transporting cars by sea may seem like an ordinary shipment, but the larger the ship becomes, the more dangerous every detail is. A powerful storm can shift the cargo. Sea salt slowly destroys metal, and a fire inside one of these vessels can, within minutes, turn the entire ship into a giant trap in the middle of the ocean. Now you will see how these gigantic car carrier ships are built from the inside, and how these floating giants transport thousands of vehicles across the ocean. 300 meters long and as tall as a 15-story building, this ship looks from the side like a giant iron box that could topple over with the first strong gust of wind. Inside, however, the structure is almost empty. There are no massive walls or divisions, only 12 thin decks stacked with thousands of brand new cars. The biggest mystery is how to keep this gigantic machine balanced in the open sea. After all, the ship's center of gravity is extremely high, while massive ocean waves crash beneath the decks. The danger of such a structure became obvious in July 2006. The car carrier Cougar Ace was sailing near the Aleutian Islands, carrying 4,812 new automobiles. During a ballast adjustment operation, the system malfunctioned. Water drained unevenly from the ballast tanks. Within minutes, the ship lost stability and tilted to exactly 60 degrees. One side of the vessel nearly touched the water, and the captain's bridge was only a few meters above the foam. An ordinary ship in such a situation would quickly lose stability. Rescue crews in helicopters were stunned. The vessel remained afloat thanks to the shape of its hull and the strength calculations of its structure. But the greatest surprise awaited the experts inside. Everyone was convinced that thousands of cars had broken loose and smashed through the deck structures. Yet when specialists entered the tilted cargo decks, they witnessed a scene that changed the rules of maritime transport forever. All 4,000 vehicles were still suspended in place at a 60-degree angle. The securing straps had withstood enormous forces. This incident proved that engineers had created a system capable of defying the laws of physics. The main secret behind the ship's stability lies in its adjustable internal geometry. The decks are not fixed rigidly. Powerful hydraulic elevators move the floors up or down depending on the type of cargo. If trucks are being loaded, the decks are raised to increase ceiling height. If low-profile vehicles are transported, the ceilings are lowered to the minimum. This allows engineers to adjust the vessel's center of gravity before departure. Ballast tanks located in the lower part of the hull are filled with seawater to counterbalance the ship's massive side surfaces. Computers calculate wind force every second, automatically regulating the water levels. In this way, strong side winds cannot overturn the steel structure. However, automation becomes useless if human error occurs. The entire balance system works under one condition: every vehicle must remain completely immobile. But what would happen if, during a storm, just one securing strap failed? A 2-ton car breaking free would begin sliding rapidly across the inclined steel deck. This could trigger a chain reaction impossible to stop inside the cargo hold, because hundreds of adjacent vehicles stand directly in its path. The gap between bumpers inside the cargo decks is often only 10 centimeters. Imagine the ship caught in a Category 5 storm. The deck beneath your feet sways violently, while the steel hull vibrates from the impact of the waves. In that moment, a single broken strap becomes a source of enormous danger. Once it starts, the process cannot be stopped until the storm ends. A similar scenario occurred in 2015 aboard the massive car carrier Voyage Osaka. Almost immediately after leaving port, the ship began listing dangerously during a turn. A heavy JCB construction loader broke free from its restraints and rolled across the deck, dragging nearby vehicles with it. Within minutes, the vessel reached a critical 45-degree list. The captain had to make an extreme decision: deliberately beach the gigantic ship on a sandbank in the middle of a busy shipping channel in order to save the crew and prevent the vessel from capsizing completely. To prevent such incidents, every modern port employs teams of professional lashers. These people are true masters of their craft. Their work follows a strict protocol. Every wheel is secured with 4 heavy-duty straps. The tension angle must be perfectly calibrated so that during any roll of the ship, the vehicle remains pressed firmly against the deck. Even the slightest looseness in a strap means that the next powerful wave could snap it instantly. The work is performed under extreme conditions. The cargo decks of car carriers are enclosed spaces with poor ventilation and constant engine noise. Inside there is a non-stop humming sound and the smell of exhaust fumes, since thousands of vehicles drive on board under their own power. Workers operate at a pace that leaves no room for distraction. A single mistake by one person in this chain can endanger cargo worth hundreds of millions of dollars. But even when all 10,800 vehicles are perfectly secured, the danger does not disappear. Inside the sealed decks, another hidden threat begins to grow. Hundreds of liters of fuel inside fuel tanks and thousands of liters of oil inside engines require special attention. The air inside the vessel itself can become dangerous. For safety reasons, engineers had to create a system capable of renewing the atmosphere inside the cargo decks several times every hour. This invisible work remains hidden from the camera. How does this complex ventilation system protect the vessel from an invisible enemy capable of turning an expensive cargo into a giant burning trap? How do you protect 10,800 vehicles from a single accidental spark when they are sealed inside an enormous steel hull without a single window? The situation becomes even more complicated because modern cargo is far more dangerous than it was 30 years ago. Today, car carriers transport not only gasoline-powered cars, but also hundreds of electric vehicles equipped with powerful lithium batteries. The problem with these batteries is that if damaged, they can generate heat even without access to outside air. In July 2023, in the North Sea, engineers faced a serious challenge aboard a car carrier transporting more than 3,000 vehicles. A fire broke out inside the cargo decks. The standard carbon dioxide flooding system used to extinguish fires proved ineffective. Lithium batteries release oxygen during thermal runaway, making it impossible to suppress the fire using traditional methods. Rescue teams sprayed the sides of the ship with water for several days to prevent the metal hull from deforming and losing buoyancy. This incident forced engineers to completely rethink fire protection systems inside sealed cargo compartments. Powerful ventilation became the primary safety tool. Modern car carriers are equipped with enormous industrial ventilation fans operating 24 hours a day. These systems can completely renew the air across all 12 decks more than 20 times every hour. High-speed airflow instantly removes flammable fuel vapors, preventing dangerous gases from accumulating near the ceilings. But how can a threat be detected in time when the cargo decks are enormous and no people are present inside? For this purpose, engineers use automated laser monitoring systems. Special optical devices continuously scan the spaces between vehicles. They react to any change in the chemical composition of the air and can detect a temperature increase of just 1 degree. If an anomaly is detected, an alarm immediately sounds on the bridge and the computer isolates the affected section using steel fire doors. The internal decks remain under constant automatic monitoring, protecting the cargo from chemical threats. Meanwhile, outside, storm waves continue smashing against the hull, trying to overturn the towering steel ship. At that moment, the ship's automatic stabilization system takes control of the balance. But how can a digital program prevent a gigantic iron vessel from rolling over when thousands of tons of water are slamming into it. Imagine a ship as tall as a 15-story building caught in an ocean storm. Waves crash into the flat sides of the vessel. Yet instead of tilting dangerously, the ship continues moving steadily forward as if held upright by an invisible force. This is no coincidence. Inside the hull operates a fully automatic stabilization system. If the computer delays its response by even 3 seconds, the rolling motion can increase dramatically. The main engineering problem of any car carrier is its enormous wind surface area. The tall sides of the ship are struck by wind forces equal to hundreds of tons. To solve this issue, engineers install active stabilizers on modern car carriers. These are steel fins that extend outward from the submerged part of the hull. Each fin is about 5 meters long. When a wave attempts to tilt the vessel to one side, the submerged fin instantly changes its angle of attack, generating an opposing force that counteracts the roll. For years, car enthusiasts believed the myth that such stabilizers could tear off during storms, but real events proved otherwise. In October 2020, an ocean car ferry crossed the North Atlantic during a cyclone where waves reached heights of 16 meters. Under such conditions, ordinary ships experience severe rolling that causes cargo to shift. Yet the automation systems aboard the car carrier worked flawlessly. Gyroscopic sensors measured hull movement with an accuracy of 1/100th of a degree. The onboard computer instantly transmitted commands to hydraulic actuators. The underwater stabilizer fins performed dozens of movements per minute, completely absorbing the energy of the impacts. At the same time, inside the double bottom of the ship, the ballast transfer system activated. Pumps moved hundreds of tons of water between tanks at speeds of 3,000 liters per second, shifting weight toward the storm side. The key is that modern systems do not simply react to rolling. They predict it before it happens. Sensors located at the bow analyze incoming waves before they strike the hull. The computer calculates the impact trajectory in advance and adjusts the stabilizers beforehand. Automation eliminates the human factor, keeping the ship upright throughout the voyage. However, older car carriers rarely use such stabilizer systems. Eventually, the storm zone is left behind, and the floating giant approaches the destination port. All vehicles remain in perfect condition thanks to automation. But now begins the most stressful stage of all, the phase where computers can no longer help. The unloading process begins, and now everything depends entirely on human precision. How does a team of drivers manage to remove thousands of brand new cars through a single ramp in the shortest possible time without leaving even a single scratch on the bodywork? This is literally precision work. One wrong steering movement can cause a collision that blocks the entire unloading process and causes massive financial losses. The operation is carried out with millimeter precision, where every person follows strict instructions. All port drivers undergo rigorous selection and training. They are known as port drivers. These specialists can park vehicles at distances of only 5 centimeters from each other while moving at high speed. Inside the massive ship, there are no normal traffic markings. All movement is controlled by coordinators using colored flashlights. Speed inside the cargo decks is limited to 20 kilometers per hour, but the pace remains extremely intense. There is no time for lengthy maneuvers. Companies measure unloading times down to the second. Real data from the Belgian port of Zeebrugge shows astonishing performance. A professional team can unload up to 300 vehicles per hour. That means one vehicle exits the ship every 12 seconds. At such speed, the risk of accidental damage becomes enormous. To prevent scratches, engineers established strict rules regarding workers' clothing. Drivers wear uniforms without exposed metal components. Jackets have no buttons, zippers, or buckles. Even shoes use special plastic fasteners instead of steel parts. The smallest metal buckle can accidentally scrape a car's fender and leave a deep mark in the paint. Another strict rule concerns traffic flow. Drivers never use reverse gear. The ship's 12 decks are designed so that vehicles move only forward along a circular route. Cars descend through internal ramps from the upper decks to the lower ones until they reach the exit ramp. This completely eliminates the possibility of dangerous opposing traffic inside narrow corridors. During unloading, drivers are forbidden from adjusting seats, mirrors, or turning on the audio system. The vehicle must be delivered to the dealership in perfect factory condition. The driver steps behind the wheel, instantly judges the dimensions of the unfamiliar vehicle, and heads toward the dock. The coordination of hundreds of workers takes place through closed radio channels, where dispatchers monitor every movement on a digital map. Finally, the last vehicle successfully rolls down the rubber-coated exit ramp onto the dock. The unloading process finishes on schedule without a single incident. But one important question remains. How does the car body stay perfectly clean after spending 30 days at sea? After all, the ship traveled through salty ocean mist capable of corroding metal surfaces. The answer lies in a special chemical technology designed to protect vehicle paint throughout the entire ocean journey. Did you know that sea salt can begin damaging a vehicle's body even before the new owner receives it? Out at sea, salty mist easily penetrates exposed body cavities. If unprotected metal remains in such conditions for several days, oxidation inevitably begins to appear. Yet all 10,800 vehicles leave the cargo decks in flawless condition, without a trace of rust. Why doesn't the salt corrode the metal? The secret lies in a special protective technology applied at automobile factories before vehicles are shipped to the port. A special protective compound known as transit wax or polymer film is applied over the paint coating. This thin layer blocks moisture, salt, and oxygen from reaching the surface. The compound is chemically neutral. It does not damage the paint, but creates a reliable barrier against the aggressive marine environment during the ocean crossing. During loading operations, when the ramps are open, salty sea air enters the vessel. Once the ship reaches its destination port, all vehicles pass through a decontamination terminal. There, under high-pressure hot water jets, the protective wax is completely removed. As a result, dealerships receive vehicles with perfectly clean factory paint. The ship itself operates during the voyage like a giant sealed thermos. The loading doors and ramps are equipped with massive rubber seals. Before departure, the crew performs mandatory ultrasonic leak inspections on these seals. Special devices detect even microscopic acoustic vibrations, indicating tiny gaps. If a leak is found, hydraulic cylinders tighten the doors further. Inside the cargo decks, automatic industrial dehumidifiers are activated. The onboard computer strictly maintains relative humidity below 45% across all 12 decks. The physics behind the process is simple. Under such dry conditions, condensation cannot form on metal parts. This completely eliminates the conditions necessary for corrosion. The unloading operation finishes precisely on schedule. Thousands of cars leave the decks under their own power. Their bodies show not a single scratch or trace of salt damage. As soon as the final vehicle reaches the dock, the gigantic steel ramp slowly rises and seals the entrance shut once again. The ship takes on ballast, starts its powerful engines, and immediately sets course for the next continent to load another shipment.